Hello, good morning, everyone. Uh, Today we shall see the features of C programming, why C programming became quickly popular, and even today it is so very relevant. So let's look at some of the important features of C programming. The first thing is it is a structured programming language. So what do you mean by structured programming language? So any programming language which allows you to organize your code systematically and allows the control to flow in a very well defined way, such a programming language is called structured. And this is achieved through the use of functions and also the use of the control statement that you have seen yesterday. So, though there is a go to statement which will allow you to randomly jump to any location, but this is discouraged. So every C programmer should be well aware that even though there is a go-to statement, should avoid using that. It means using the regular control statements and the loops, you can get any problem solved. You don't require go-to statement. The second important thing is it is a strongly typed programming language. When I say strongly typed programming language, that the variables must be declared. All right, so they must be declared or mentioned before you. So I should have used the word declared here, before use. So if I want to use a variable a, I must declare it int a, specifying the data type of the variable. There are few languages which don't require you to specify the data type, for example JavaScript or Python. So they don't need you to declare variable. You can just say let a and start using it. Okay, so this is not a good practice because any overflow of data happens, you will not come to know. So that is why strongly typed languages are preferred whenever you are building any enterprise level application. So C stands to be a strongly typed language. Now this strongly type checking happens for the variables and also for the functions. Remember, when you write a function, function takes arguments, argument type and the number of arguments have to be mentioned and also the return type. So all these must be checked before the function is invoked so that your program runs correctly and any mismatch that is there will be detected at compile time. Okay, so that is why in C we declare what are called as function prototypes before we use them. Then next important feature of C is it's a middle level language. So because you have high level languages where you write code in only in English like statements, whereas C allows you to mix and match assembly code alongside the high level statements. Now this makes your programs way faster than the other high level languages because assembly language, as you know, is closer to the machine. So the conversion happens quickly and the execution happens much faster than using only high level language statements. The next very important feature of C language is it is very simple to learn because you only have to use 32 keywords. So whenever you're learning any language, for example English, you need to know a lot of words before you master the use of the words in sentences and all that. Whereas here, the number of words that you use to write your programs is limited to only 32 keywords. In fact, you'll be using just 20 to 25 of them at any given point in time. So you have an easy learning path when it comes to C programming. The next thing is it supports large set of standard libraries. It means you don't have to write code for everything. For instance, you want to find square root of a number, you don't have to write program to do this. There is a library function to do that. All right. Similarly, if you want to concatenate two strings or compare two strings, there are library functions. Similarly, you want to do some graphic stuff like you want to draw a circle or draw a line or draw a triangle. You have library functions for that, right? So C has a rich set of libraries which makes it ideal for developing applications quickly. The next feature of C is it is faster execution. That is, you can write very efficient and fast code through use of pointers. You go to any other programming languages, there are no pointers. Though use of pointers leads to ugly programming code, but it is very, very efficient. Similarly, it allows you to write assembly code alongside C, and it allows you to use register variables. As you know, in a microprocessor, there are registers. For example, register A, register B, and so on. In 8-bit microprocessor, on 32-bit, it is AX, BX like that, and on 64-bit, it is E, AX, EBX, and so on. So the use of these register variables will help you do the processing within the CPU, which is much, much faster than getting the values from the memory. So these are some of the very important features of C programming language, which will attract many learners. And today we still see a lot of people using C programming, especially when it comes to developing networking software. The the four-layer TCP/IP protocol stack is wholly implemented in C. And when it comes to embedded system, it's all C programming. When it comes to operating system, it's all C programming. So C program is still in use in all enterprise level applications, and it is worthwhile to learn it well. All right. Now let's move on. Loop variations. I gave you an idea of what loops are. If you want to do any repetitive task, we use loops. But there are few variations that you can be aware of and use them judiciously. For example, I can implement for loop just like a while loop. So for instance, if I say int I equal to 0, and in the for loop, I don't mention anything as the first part here. Traditionally, I would have written int I equal to 0, but I don't do anything. Then I less than equal to 5. Then this I plus plus also I can omit. And here within the block, I do some printf here. So some string, and then do I plus plus here. So what happens is this for loop runs just like a while loop. The initialization of index variable I happens here, and the increment of the index variable happens within the loop, and this will continue till I reaches 5. So 6 times hello will be printed. All right. So this is one small variation that is possible. Now, one problem that many a times uh, student encounter while using for loop is that putting a semicolon at the end of for statement. To illustrate that, for example, I have a regular for loop where I say I equal to 0, I less than equal to 5, and you have I plus plus here. What happens if I try to print the value of I here? I equal to percentage %d, and I have to slightly modify this, double quote here, comma I. Now this will work well. It will print I0, I equal to 0, 1, 2, 3 up to 5. But what happens if I write semicolon here? If you put a semicolon, as we say, every statement in C program should end with a semicolon. So accidentally while typing, many a times beginners do put a semicolon after the for statement. What happens here is it will treat a semicolon as a null statement. Null statement means do nothing. So it's like this. It will do a null statement. What happens now is I equal to 0, it will go here, do nothing, come back, increment I by 1, again go here, do nothing, come back. So when I becomes greater than 5, that is 6, it will come out of the loop and it execute this printf only once. So what gets printed on the output is not I equal to 0, 1, 2, 3 up to 5, just I equal to 6 is what gets printed on the output. So know these small pitfalls whenever you are writing C programs. By accidentally putting a semicolon or habituated to put semicolon after every statement, this could well happen. So you should know what is happening here. All right. Yeah. Now, normally we use for loops to go in the forward direction. It is also possible to go in the backward direction. That is, can I have initial value of I 5 and go I becomes great, repeat until I becomes greater than equal to 0. So that is also possible. So these are some reverse loops that you should be aware of. For instance, if I want to print from 5 to 0, then I would write initial value of I as 5, I greater than equal to 0, then here I minus minus and printf I. So what happens now is that initial value of I is 5, so I gets printed on the screen. Then if I put a slash n here, I is decremented by 1, it becomes 4, so 4 gets printed, 3 gets printed, 2 gets printed, 1 gets printed, and when I becomes 0, still it enters the loop, and when I becomes minus 1, it will come out of the loop, and this is what you see on the screen. Alright, so the reverse printing of numbers is possible by using you know the initial value other than 0 or 1. So you are free to choose any initial value here. Correct. So further, these individual parts of for loop can contain expressions. I mean, it need not be that I equal to 5. It can be an expression containing some variable. So how do I handle that? So let's say we have other variables here. We have other variables int I a equal to 5 and b equal to, let us say, 4, and then I can say a into b as the initial value, then a less than equal to b square, that is b into b, then I plus equal to 2. So instead of I plus plus, I write I plus equal to 2, which is same as I equal to I plus 2. It means I want to increment I by 2 every time. As you can see, each one is a expression here. This is also an expression. This is also an expression which is doing some calculation. All right. So now in such a scenario, what happens? So now if I say printf, can you guess what will happen here? If I say printf hello, how many times hello will be printed? Now we see that 5 into 4 is 20. So initial value of I is 20. I less than equal to b square. What is b square? 16. So I is already more than 16. So it will come out of the loop. It will not print anything. You getting my point? Okay. So if initial value is more than the final value, it will come out. Okay. On the contrary, if I say plus 8, that is b square plus 8 as the expression here by adding 8. Now what happens? 16 plus 8 is 24. So initial value is 20 and you have 24. So it starts with 20. It will print hello once. Then I equal to I plus 2. From 20 it jumps to 22, again prints hello. Then again it jumps to 24, again prints hello. But next time it jumps, it will jump by 2, so 26. So 26 is more than 24, so it will come out. So 3 times hello will be printed. Okay. So whenever you use for loop, the three parts: initialization part, then conditional part, and the increment part. These can be expressions. So be aware of these small variations in the for loop. All right. So you can also check with while loop. Again, putting a while semicolon at the end of while loop may cause some problem, more severe than your for loop. For example, if I say while I less than equal to a, put a this thing, and initial value of I, let us say 2. Okay, and here you are doing flower bracket and printf hello, and let us say I plus plus. Now, since you have put a semicolon here, this loop will rotate here only. I will be 2 and A will be 5. This will always be true and this will never come out. So your program just hangs. Okay. So it's more dangerous to put a semicolon here than use semicolon in for loop, where now if you remove the semicolon, then things will be fine. So it will enter this loop because I is less than 5, so it will print, and then I will be 3, 4, 5, and when it becomes 6, it will come out, and those many times that hello will be printed. All right. So this is about the variations that you see in a for loop or a while loop. Okay. Now I just now showed you expressions in for loop. That is all that was covered. Now coming to logical, the different operators that are there in C. So you should do a detailed study of what are the different operators that we have and how do they affect your computations. Now we have seen relational operators, that is we have seen relational operator less than, greater than, less than equal to, greater than equal to, not equal to, equal to. So these are all called as relational operators. You know how to use them now. Okay. Then logical operators. Now there are logical operators and, or, and, not. These are called as logical operators. Now what are these logical operators? How do they help? We'll see shortly. Then we have bitwise operators, which is bitwise and, bitwise or. Okay, bitwise uh, inverse, invert the bits. Okay, and bitwise XOR is also there. So this is bitwise operators. Okay, and there is a ternary operator, which is a question mark. This is the ternary operator. All right. So it is important to know the distinction between the various operators that are there. Now, AND operator is used to connect two relational expressions. For example, if A greater than B and A greater than C, or like this, you want to print A largest. Without this AND operator, you would have used two if statements here, right? Yesterday we have seen that. So using single if statement, you can combine two relational operator expressions and use AND operator. All right, so this is useful to do more in one statement. Okay, so this is a AND operator. Likewise, you have OR operator and NOT operator. All right, so you will learn them as and when they are required. Similarly, bitwise AND is slightly involved, and we need to understand the binary number system for that. We all know that decimal number system start with 0 and end with 9. So there are 10 symbols here, and you can write any number using any, one of these 10 digits like 1, 2, 4, 7. We are familiar with this. But computers work with binary numbers because, as you know, all the circuits in the hardware of the computer is made up of logic gates which will understand only 0 and 1. So in binary format, a 0 is represented by all zeros like this. 1 is represented by 0001, 2 by 0010, 3 by 011. Likewise, as you can see, the bit is shifting one position to the left as you add more bits. So you should at least remember the binary representation of first 10 numbers. Okay, now how do I know that it is a binary representation of 3? So the base of this number system is 2. It means there are only two symbols, 0 and 1. Okay, as you know, the base of your decimal number system is 10 because there are 10 symbols. Likewise, in binary, there are only two symbols. Now, using this, you simply have to multiply each digit with 2 and add them up and raise the power of 2 from left to right, 0, 1, 2, 3, like that. So anything multiplied with 0 is 0, here also 0, here it is 2 is to 1, 2, multiplied with 1 is this, 2 to the power 0 is 1, so 1 into 1 is 1, so this turns out to be 3. So you can check with any number here and you will see that when you multiply each bit with 2 and raise to the power from left to right, you will get the corresponding decimal number. So there are bitwise operators, like for example, if I say int a equal to 5 and b equal to 6 and say int c equal to a and b, what will happen? Okay, so here we need to represent a5, which is 0, 1, 0, 1. This is a, and b we have to represent with 6, 6 is what? Here, 0, 1, 1, 0. And we have a truth table for AND logic, that is AND gates work like this. If any of the bits are 0, you will get output as 0. Any of the bit is 0, you will get 0 again. Either of the two bit is 0, 0. Only when both inputs are 1, you get 1 here. So if we apply the same to here, 1, 0, one of the bit is 0, so output is 0. Here also 0, 1, 0. 1, 1 is 1. This. Now 0, 1, 0, 0 is 4. 0, 1, 0, 0 is 4. So here. So output when I print C, you will get 4. Alright. Similarly, if I use OR logic, instead of this, if I put a OR logic here, so what would happen is, again you have to go with the OR logic. The OR truth table is here. Any one bit 1, you will get output as 1. So as you can see, any one bit in the input is 1, the output is 1. Only when both bits are 0, you get 0. So here if you see 0, 1, 1, 0, 1, 1, 1, 1, 1. So you get output as 0, 1, 1, which is 7. So depending on which operator you use, it will give you different output. We have one more operator, XOR operator, and the XOR truth table is something like this. This is, if it is XOR, then 0, 0, 0, sorry, uh, 0, 1, 0, 1, 0, 0, 1, 1. XOR with this. So this is correct. So only when both bits are of same type, then you get output as 1. If I'm not, sorry, this is, yeah, this is not correct. Uh, just 1 minute. So the XOR work like this. If the one of the bit is 1, then output will be 1. Otherwise, if both bits are same, then it will be 0. Okay, more or less exact opposite of your OR gate. So this is the thing. Now if I apply the same to my expression here by replacing this with XOR operator. Note the symbol for XOR, it is a cap symbol. Now 0, 1, 0 will give you 1, 0, 1 will give you 1, 1, 1 will give you 0. So what you get is 3. Okay. So this is bitwise XOR. Alright. So these are some of the things you must be aware of, especially when you're working in the embedded domain. You have to work with binary numbers. Similarly, we have left shift and right shift operators. That is, a number can be shifted to the left or right. For example, if it is a equal to 5, and if I say a equal to a left shift by one position, then what happens is 5 is 0, 1, 0, 1. If you left shift by 1, this 1 will be shifted here, 0 will be shifted here, 1 will be shifted here, and 1, 0 will be appended. So this is 5. When you shift to the left, it becomes 10. Okay. Similarly, right shift. If I say b equal to b right shift by 1, b is 6. Right? 6 is 0, 1, 1, 0. So if you right shift, this 1 will get shifted to the last position. This 1 will come here, and this is 0 and this is 0. So you see that this is 3. So b value will be 3 after shifting, and this will be 10. Okay. So as you can, if you observe, if you shift to the right, the value is becoming half, and if you shift to the left, it is becoming double. So this one property you must know. In some situation, this is useful. All right. So we have seen all the operator. The ternary operator needs to be seen. So what is this ternary operator? Ternary operator is useful when you want to implement, if statement, if then else statement in a short form. For example, a equal to 5 and b equal to 6. Okay, and you want to get the larger of the two in C. So you can write C equal to a greater than b. You put a question mark. If so, you assign a to C. Otherwise, you assign b to C. Now what happens is it will check whether a greater than b. It is not true. So the else part gets assigned to C. So C will get 6. Okay. So ternary operator is useful to implement if then else statement in a very short form. So this you must also note. Especially when you write macros, this ternary operator will be useful. We shall see what a macro is and how to write using the ternary operators later. Now moving on, arrays. As you all know, arrays allow you to store a collection of data objects of the same type. If all data objects must be either integers or char or float or double, any data type, but you cannot have mixing of float with integers and all. Now arrays are useful whenever you want to store large number of values. So you cannot have one variable for each value assigned. Let's say you want to store 100 marks. So you cannot say M1, M2, M3 up to 100. So that is very clumsy, and it's very difficult to remember all the marks and access them. Instead, you can declare an array like this: data type, name of the common name for all the objects in the list, and size of the array. So how an array get allocated memory is your marks 0 is in one location, marks 1 second location, like that up to 99. So this first part is called as index variable. So using the index into the array, I can access any element. Just provide the position of the element in the array and you'll get that value. For instance, if I say marks 7 equal to 11, So at position 7, you get 11 stored. All right. And if I say int a equal to marks 0, then 5 will be stored in A. Right? So arrays are very, very useful, and we'll be using them extensively. So a demonstration of few of these things we shall see uh, in the code block. So let's see int a equal to, sorry, uh, int marks square bracket, and you can initialize, declare an array with a square block symbol and initialize them to some numbers like that, like this, and put a semicolon. So this is an array of 5 marks, and if you want to display all of them, you can use a for loop, and we require an index variable which you can declare before this. We say int I equal to 0, I less than, now 5 elements are there. I can say I less than 5 or less than equal to 4, either way, I plus plus, and say printf percentage d, and then comma marks of I. And if I run the program, I should get all the marks displayed. Of course, I should have left some space here. So since all are displayed on the same line, you can leave a space or put a tab. So tab will space them properly. As you can see, 12, 14, 15, 11, and 5. So these are the 5 values which are stored here. Okay. Now what happens if I put a semicolon accidentally? All right. So you'll see only 5 getting printed. Okay. It is displaying the last value, because when I becomes 5, this will come out. The for loop will terminate here, and if I put some 99 here, it should print that last value in the index. So 99, and what is coming, because I would have reached 5 at 5th position, there was nothing, it was just displaying 5. It depends on the compiler, it was putting this 5 only next, so it was getting there. Now if I put 99, that is what comes out. So if I really wanted to print all the marks, the correct ones, you should not have put a semicolon here. So that's the right way of doing it. All right. So we can use arrays for storing a large number of things. So one simple example about bitwise operators, that a equal to 4, b equal to, let us say, 7, and comma c equal to a XOR b, and if you say printf c equal to percentage d comma c. Now what do you expect here? So we have to do some calculation. So we know that a is 4, so 0 1 0 0, and this is XORed with 7, so it is 0 1 1 1, and we know you have to go bit by bit. Last bit with 0, so opposite values are there, so we'll get 1, then 0 1 again 1, then you see 1 1 there, that is third bit here and third bit of 1, so same bits 0, so this will be 0 0 0. So you should get 3 as the output. So let's see whether you get that. Yeah, you get c equal to 3. All right. So bitwise operators are very useful, and they're used widely, especially in image processing and all. Bitwise operators are used even in embedded systems. So you should be familiar with the binary numbers and how to use them to get the uh, you know the output the way you wanted using the expressions. All right. So We shall close here, and in the next class we shall see more on arrays and how to use them to you know implement or solve some of the practical problems. All right. Thank you for watching.